Welcome to the second in a series of tutorials covering Snap with Finch and Hummingbird. This tutorial will explore using the Finch in Snap. We begin by discussing each Finch block and its capabilities, followed by how you can use Snap to build a simple robot program and a simple sensor graphing program. So to begin, I'm going to plug in my Finch and launch the BirdBrain Robot server application. And I'll click on Open Snap. And now I have access to all of the regular Snap blocks as well as some custom Finch blocks. So the Finch blocks are, starting with movement, these are in the motion category, move Finch left and right, and this sets the power to the wheels. So for example, move left 100, right 100 will turn the Finch on forward full power. And I can click on Stop Finch to stop it. If I want to turn left, for example, I'll do left 100, right minus 100, and so on. So the range in these values is negative 100 to 100. And the Stop Finch block is there mostly for your convenience, so you can always click on this if your robot is running off the table or something like that. Under Looks, we have the Finch LED block. And this has three arguments, red, green, and blue, RGB, and their values range from 0 to 100. So if I want to turn my Finch beak LED on to red, I make red 100, green 0, blue 0. If I want to make it yellow, then I'll set red and green to be 100. And that'll give me roughly a yellow color. And so on. So there's white. Under sound, I have three custom blocks. The first is called Say This, and it's actually a text-to-speech block. So this will come out of the computer speakers, and if I type something in here, any text will do, and I'll have it say. So it says, "This is a Snap tutorial." I also have the Finch buzzer block and the Finch buzz plus wait block. Now the difference between these two is that Finch buzz plus wait will block the rest of the program from happening for half a second. Finch buzzer will not. So the best way to illustrate this is if I duplicate this block and make a tone of 440 Hertz and then 880 Hertz, you will only hear the higher frequency, because it will immediately go from this block to the 880 Hertz block, and so it overrides the 440 Hertz block or the 440 Hertz command. If I use the wait block, you'll be able to hear both. So those are all of the output commands. For inputs, we have a number of sensing blocks. So the Finch left light sensor and right light sensor, these range from 0 to 100. So if I click on any of these sensor blocks, I get the current state of the sensor. And if I cover that light sensor, now it's 4, now it's 25. It's kind of dim in my room right now. Right light sensor, 19, now it's 3. If I click on light sensors, I get a list containing the left sensor value and the right sensor value. For acceleration, this is in g-forces. X is currently around -1, Y is 0, Z is 0. The orientation is beak up. So right now I have my Finch sitting on its tail on the desk. And then if I click on Finch accelerations, that's a list again with X, Y, and Z values. The obstacle sensors are false or true. So if I get an obstacle, now they're true. And we get a list. And then we have the temperature block. So right now it's about 24 degrees Celsius or 75 degrees Fahrenheit in the room that I'm in, according to the Finch. So we just discussed all of the Finch or Hummingbird blocks. Let me now also discuss some of the regular Snap blocks in the interface. This is not meant to be a full tutorial on Snap, and so we're not going to cover every single block, but I do want to give you an idea of the important ones. First of all, you should note that if you right-click on most of the blocks, there will be a Help section which can tell you what the block does. So Snap is mostly about programming animations and games within this canvas area. So this move 10 steps block just moves the sprite over 10 steps. Turn will turn it. You can have it point in a certain direction. You can have it go to a set of coordinates or glide there. You can change x, set the x coordinate. You can change the y coordinate by 10 or set the y coordinate to a value. And then there are some sensors like what's the x position, the y position, and the direction right now. In looks, you can make these sprites have, let's bring this back. You can make the sprites have different costumes. So if you go to the Costumes tab and drag in a JPEG or PNG file, the sprite will become that image. And if you drag in multiple ones, you can use this switch block to change between the different images. You can have the sprite say hello for a couple seconds or just say hello. You can also have a thought bubble, so very cartoonish. There are ghost effects and other graphic effects. You can change the size, make it bigger or smaller. In sounds, you can drag sounds into the sprite and have them play those sounds, so little wave files. You can also have it play notes or beats. This is all through the computer speakers, of course. Under pen, you can put the pen down, and then when you move the sprite with the motion commands, it will draw. You can clear that. You can change the pen color, change the pen shade, change the pen size. Under control, these are all structures for program control. So for example, if I go back to the scripts tab here, and if I use a when flag is clicked, when I click the green flag, it'll do all of the blocks that I've put under here. So if I put a move and a turn, then that's what it does every time I click. Same thing when I press a key, like the space key, up arrow, left arrow, whatever, it'll do whatever is under there. When I am clicked is simply, when I click on this block, it'll do whatever is under there. There are ways to broadcast sensors between different sprites or different parts of different scripts. And so you can create a broadcaster and have a receiver. You can have multiple sprites, and you can have, all of them react to the same thing. So if sprite 3 does point in a certain direction, sprite 2 does maybe go to XY, and sprite 1 does that, we'll change things around when the flag is clicked. There's a wait command which just waits the program for a certain, or blocks the program execution or the script execution for a certain number of seconds. You can use a decimal point to do less than 1 second. You can wait until a Boolean expression, that's what this hexagonal block is, returns true. You can create a loop that executes forever. Whatever is in here, it'll do it forever until you hit the octagonal stop button. You can have a counter loop, so it'll repeat whatever is in here 10 or whatever number you want to put in here times. And again, you can have a repeat until loop, so it'll repeat whatever is in here until you have something return true. You can have if statements. You can have if-else statements. You can report values, stop blocks, stop scripts. Under sensing, you can detect if one sprite, so for example, if I'm in sprite 2, I can detect if I'm touching sprite 1 or sprite 3. You can rename your sprites. You can detect if you're touching a color in case you're drawing a pen trail. This block allows you to detect if a key is pressed. This block will return the distance to the sprite. So distance from sprite 2 to sprite to the original sprite is 214 pixels roughly. There's a little timer block and a timer counter. There's an HTTP GET block, which returns the value at that web address. This is actually how we communicate between Snap and the BirdBrain robot server. And then there's turbo mode. For operators, we have plus, minus, multiply and divide, modulo, round, square root, random numbers, less than, equal to, or greater than, and or not. So if this and this is true. We can join strings together. So join hello and world into hello world. We can do string manipulation. So letter 3 of world is R. What's the length of, whatever you put in here. And then this category of variables and lists is very important. You can make your own variables. So let's say we made a counter variable. We can set the counter variable to a value. So let's say that if we press space, we'll set it to 0. If we press the up key, we'll increment it by 1. And if we press the down key, we'll decrement it by 1. So I'm pressing down a whole bunch. I press up, and if I press space, it goes back to 0. There's also lists. So these are analogous to arrays. So you can get item 1 of the list, all but the first item of the list, and so on, the length of the list. And then finally, you can make your own blocks. And so if I made a block in the motion command, let's call it move and turn. We could have, a block that moves the sprite, turns it 15 degrees, and so now it'll show up down here, and if I click this, it moves and turns my sprite. Something that's important to note with all Finch and Hummingbird blocks, I have some Finch blocks open here. These are just custom created blocks out of other Snap blocks. So if I right click on them and hit edit, you can see exactly how this block is constructed out of other Snap blocks. And if there are any blocks that you feel are missing, like if you want a move Finch forward, in a straight line, that takes only one argument, you're free to create your own block that just, makes it out of the move Finch block. So that's a very brief overview of the overall Snap interface. So now let's use this to make some Finch or Hummingbird programs. So we're going to use some of the native Snap or Scratch blocks to create a program. It's going to start when I press the space key. And I will have a loop that repeats until I press a Q key. So that's the key pressed. And I'm going to have a couple of if statements. And I'm going to use the left obstacle and right obstacle sensors and put them into these if statements. So if I see something on the left side, I'm going to do whatever I put in here. If I see something on the right side, I'll do whatever I do in here. So probably if I see something on my left side, I should move backwards. So that's minus 100. So I'm going to move backwards full speed. And I will also, I'll do that for about 7/10 of a second, let's say. And then I'm going to turn a little bit. So I'll move with my left wheel. Actually, let's make that sort of an arc. So do -50 here, -100 here. And I'll do that for about half a second. And the other thing I like to do is I like to use the LED to show me what part of the program I'm in. So I'm going to make my LED red if the left obstacle, if the Finch sees something on the left side. Now I'm also going to click and duplicate this to use it for the right side, but instead of red, I think I'll make it blue. And I'll make it go backwards still, but turn in a different direction if it sees something on the right side. Then finally, if I don't see anything, or if there's nothing going on here, I will just tell the Finch to go forward, maybe 80% speed. And I'll tell its LED to be green because it doesn't see anything. So if I hit the space key, my Finch starts, it's going forward. If it sees something, you'll have to believe me, the LED just turned red, and it just turned blue. And if I hit Q, the program ends. But I did forget something important here. I forgot to stop the Finch after the program ended. So I should pull in a stop Finch. I always make that mistake. So I have a program now. Let's save it. There's several ways that I can save this. I can do a save as, and I can save it into my browser's cache. And this is nice. This is a local way of saving the project. So I'll save this as obstacle avoider. And this will save so long as I don't delete the cache in my browser. And obviously it only saves to the browser I'm using right now. So I'm using Chrome. If I were to open Firefox, it wouldn't be able to load it into this. I can also log into the cloud. I'm already logged in. But if you click on cloud for the first time, you'll be able to create an account. And I can save it to the cloud. So if I do save as, I'll just save it as obstacle avoider again. So now it's saved to the cloud. Now my last option is if I want to create an XML file, I can do export project, and that exports it to a new browser window. And this is a bit tricky, but I have to go and save this page as an XML file. So I'll rename it from the crazy file name it's given to obstacle avoider or something similar. And I'll save that. Now if I want to import that file, if I go just to the Snap website, and if I now go to import and go to my downloads where I downloaded the file and find obstacle avoider .xml, it will import my project. So there are 3 different ways to save. Each of them has their advantage and disadvantage. If you choose to launch Snap locally, you won't be able to do the cloud storage option. Okay, so let's create a new file or a new program now in which we use the canvas to graph a sensor value. So again, we'll start by starting when the space key is pressed. And in this case, we're going to use the pen. So the first thing we probably want to do is put the pen down. We want to move the sprite over here to be close to the edge of the screen. So -240 on the x coordinate, 0 on the y coordinate. Then we want to clear the screen before we enter a loop. Then in control, if we do another repeat until, and again we'll just do the key Q is pressed. We can change X by 1, so we're slowly scrolling across the screen. And we'll set Y to a value determined by one of the sensors. So let's say that we wanted to graph the X acceleration. We know that it's a value that goes between -1.5 and 1.5. So we probably want to multiply that a bit. So let's multiply it by 100. And we'll set Y to that. And then we'll also check if our sprite gets to the edge of the screen. We probably want to head back to the beginning. So we'll do an if statement. If the sprite is touching the edge, then we want to do these three things again. So do a duplicate, we'll get rid of this stuff, we'll go here. Alright, so let's see if I did that right. And I did actually make a mistake. I had initially set X to -240 and that was too far towards the edge. So I changed it to -200 on each of these. Now if I hit space, my Finch is level. Now if I shake my Finch, it's graphing the X acceleration data. So, and it's fairly easy, you know, to replace this with, let's say, instead of setting Y to something based on the X acceleration, let's make it the left light sensor. And now we have the same style of graph, but if I cover the light sensor, you can see the value dip, otherwise go up, otherwise dip. And you know, this seems like it could benefit from a multiplier also, but maybe multiply by 5. So there you go. That's how to quickly make a graph with Finch sensors. You should now be ready to start making programs with Finch in Snap. Thanks for listening.